Hello everyone, in this Thierry Sicard tutorial number 33 we will return to how scientists have made a link between electricity and magnetism through Luigi Galvani, Volta and its battery invention, then Ørsted experiment and finally Ampere and the Ampere's law. Galvani was known as a specialist of bioelectricity. Almost on all the Galvani picture you can see dead frog's legs. He was doing experiment with dead frog legs, touching the frog's legs with two different metal type, was able to contract the legs muscle so the legs was moving. He coined the term animal electricity. At the beginning, Volta embraced the idea and repeated a lot of experiment of Galvani. But Volta started to doubt that the electricity came from the animal. Volta was convinced that the electricity came from the different type of metal. Volta did the battery to demonstrate that we could create electricity without animal, but just by using two different metals with salt between them to replace the physiologic serum of the animal, which is water plus salt. The battery was invented in 1799 by Alessandro Giuseppe Antonio Anastasio Volta. Fortunately, we just keep volt for the voltage unit. Volta worked with great scientists as Lavoisier and Laplace. He was aware of Galvani experiment, but at the end he disagrees with Galvani theory. Volta published a letter in French on March 20th, 1800 for the battery invention done the March 17th. The May 2nd, 1800, already two English chemists do the first water electrolysis by using the Volta battery. In November 7th, 1801, Volta present its battery at the French Institute. For the first time, we were able to do a DC voltage and current at the same time. Before this date, it was just electrostatic, so we could do a DC voltage, but not a continuous current. This continuous current provided by the Volta battery allows Ørsted 20 years later to bring enough DC current in the wire to see the magnet needle moving. Ørsted, with the students in the Copenhagen University, was using the battery invented by Volta 20 years earlier. As they connect resistive load to the battery, in fact it was different type of metal wire, they were studying the fact that the wire was warming up, later known as the Joule effect. At that time, all the scientists had in their laboratory this strange magnetic needle which pointed all the time in the same direction. The magnetism and electricity were two separate fields of study until 1820. I am saying until 1820 because Ørsted, during the experiment, noticed that when the needle was close enough to the wire, the needle was moving when the wire was connected to the battery. For the first time, with this experiment, the two distinct domains of magnetism and electricity will never again be separated, but the two domains join into one to form the electromagnetism. The story says that Ørsted did not say nothing to their students and did again the experiment alone. The experiment was as follows. The magnetic needle was close enough to the wire and parallel to it. When a current was flowing in the wire, means connected to the battery, a DC current flows in the wire and the needle turns of the alpha angle. If the current continues to increase, the needle will be perpendicular to the wire at a maximum angle of 90 degrees. Ørsted works to find a theoretical explanation, but as he could not find, after a few months he published its experiment. André-Marie Ampère is born in Lyon, the January 20th, 1775. His father was a rich silk merchant from the Lyon area. Ampère is a mathematician, physicist, chemist, and philosopher. Self-taught, he trains himself freely by drawing from his father's library. Ampère contributed to the development of mathematics in physics. In 1820, Ampère was traveling in France when he saw a presentation of the Ørsted experiment where the magnetic needle was turning when some current flew in the wire close to the needle. The next week, he wrote 2 papers where he explained the link between the electricity movement and the magnetic action. This is the Ampere's law. If a current I is flowing in a wire of radius A, the circulation of the vector H on a closed circuit, here the perimeter 2 pi r, is equal to the current which crosses the surface delimited by the circulation of this vector. For r greater than A, H equal I over 2 pi r, so the H is proportional to 1 over r. For r smaller than A, H is proportional to r, so dH over dr is equal to the current density. Initially, Ampère was working on other domain with the law of Avogadro-Ampère, so he really started to work on electromagnetism only at 45 years old. He proposed the modern word as tension and current. He died on June 11, 1836 during the Marseille University visit. Ampère invented the solenoid and he demonstrated that it was equivalent to a permanent magnet with south and north pole. A mnemotechnique allows to find the north and south pole of the solenoid by writing the letter S and N. The ancestor of the capacitor is a Leyden jar. It was known around 1745 and Franklin used it to store electric charges to demonstrate in 1746 that lightning was an electrical phenomenon. Now, since 1820, a new component is available. It is a solenoid called also coil or inductor. It is noted L. As we already discussed in the Thierry Sicard tutorial number 4, this new solenoid element will be fundamental in the electromagnetism theory because the capacitor C will be linked with the electrical constant vacuum permittivity or distributed capacitance of vacuum N equal to epsilon 0 equal 8.8 picofarad by meter. And the inductor L will be linked with the magnetic constant vacuum permeability or distributed inductance of vacuum and equal to μ0 equal 1.25 microhenry by meter. L is a fundamental new element in addition of the capacitor C because epsilon and mu are fundamental constant of the material or vacuum for epsilon 0 and μ0. The speed of light in the vacuum can be defined by the formula epsilon 0 μ0 c square equal 1. I want to thank you for your attention. On my next Thierry Sicard tutorial number 34, we will talk about the Faraday's law of induction and the first electromechanical generator. So, see you soon and stay tuned.